today we are going to discuss about Fischer Esterification, in which there is acidic conditions are met and it is done in the presence of concentrated H2SO4 such as sulfuric acid. So what we do is we take a carboxylic acid and an alcohol, we react it under the conditions and then we form an ester with the removal of water. So that's the carboxylic acid, that's the water molecule. So now we may see the mechanism of the reaction. The first step is, it occurs in 4 steps. So the first step is the protonation of the carboxylic acid. It occurs to make the carboxylic acid more electrophilic. So the carbonyl group becomes more electrophilic and the carbonyl carbon actually becomes more electrophilic. So what we have here is the carboxylic acid. We add the proton here in the presence of concentrated H2SO4. So this, what happens is the oxygen has lone pair, so it is partially electronegative and the carbon is partially electropositive. So the H plus attacks to the partially electronegative oxygen and hence this oxygen makes 3 bonds. So what we do is we take this and duplicate it over here. So the electropositive carbon reacts with this ethanol molecule over here, and then what happens is, I forgot to mention, I'm going to shorten it. And then this step, I'm going to write the step that attack of OH minus of alcohol which acts as a nucleophile to the electrophilic carbon. So what happens is, when we protonate it, it acts more electrophilic. So OH, which is a good nucleophile, it attacks to the carbon, electrophilic carbon center, and then it forms this structure over here. Now, what I forgot to mention is the OH is positive because it forms 3 bonds, because it's utilizing one of its lone pairs. What's going to happen is, this complex is going to be formed. Let's just write the CS ethanol as like this. So now the third step is the transfer of hydrogen ion to OH negative. So the OH negative is going to have the H positive give off its bond and attach itself to make a water molecule. So in order to remove it, transfer occurs. So the carboxyl, that's I'm going to copy here. So what happened over here is, the proton shifted and it broke the bond between the oxygen, and now the OH is going to form, and then now the hydrogen is there and the oxygen is there. What's going to happen is, in the 4th step, so the positive is there also, and then in the 4th step, the removal of water and H plus ion occurs. So what's happening here is, the H plus ion gives off the bond and the water also gives off the bond. So let's duplicate this. So the double bond forms, and we have now is, we write it over there, we have here is ethyl acetate. Hence this is Fischer Esterification with the removal of water and H plus ion, which is H3O positive.